this lesson we will be sketching parabolas using the quadratic formula to find our x-intercepts. So far we've found the x-intercepts by factorizing, and we've found them by completing the square. Now we'll find them by using the quadratic formula. So let's just jump straight into a question. Sketch y equals 2x squared plus 4x minus 3, labeling all key features. So if you're being asked to label all key features, that just means your turning point and your intercepts. And hopefully you recall that the reason why we sometimes use the quadratic formula to find our x-intercepts is because sometimes quadratics can't be easily factorized, and so it's easier to use the quadratic formula to find the x-intercepts. So firstly, let's find our y-intercept by letting x equal 0. So we'll get y equals 0 plus 0 minus 3, so y equals minus 3. Find our x-intercepts. Let y equal 0, and so we'll solve 0 equals 2x squared plus 4x minus 3. Now this is where the quadratic formula comes in. We can solve for x by using the formula x equals minus b plus minus the square root of b squared minus 4ac over 2a. Hopefully that rings a bell from you from when we looked at it in the quadratics topic. So it'll be helpful for you to recall that the general form of a parabola is y equals ax squared plus bx plus c. So for us, we'll have minus b will be minus 4 plus minus the square root of 4 squared minus 4. Our a is 2, our c is minus 3, all over 2 times, and our a is 2. Now let's keep going with this. We'll get x equals minus 4 plus minus the square root of 16 minus 4 times 2 will give us minus 8 times minus 3 will give us plus 24. So 16 plus 24, make that a little bit shorter, all over 4. Now if we keep going with this, we can simplify it a little bit more. Minus 4 plus minus the square root of 40 over 4. Again, I think we can simplify this even further. X equals, using surds, simplification of surds, minus 4 plus minus root 40 is root 4 times root 10, which is 2 root 10 over 4. Now it looks like we have a common factor of 2. So let's take out the common factor of 2. This will become minus 2 plus minus root 10 over 4, and then we can do some cancelling. That can cancel, and that 4 can become a 2. So we are left with x equals minus 2 plus minus root 10 all over 2. Now, in terms of labeling our x-intercepts, the question might specify that you can round your answer to 2 decimal places. So I'll just go ahead and do that now for us. X equals 0.58 and minus 2.58 to 2 dp's, 2 decimal places. Alrighty, So we've got our y-intercept, we've got our two x-intercepts. The next thing we're going to do is find our turning point. Now you'll recall that in order to find the turning point, we need to find the axis of symmetry. And hopefully you'll recall the rule for finding the axis of symmetry is x equals minus b over 2a. We can just take the average of the two x-intercepts. If we're working with these decimals though, that can become a little bit tricky, so it might be easier just to take minus b over 2a. Our b was 4 and our a was 2, so that'll be minus 4 over 2 times 2, so we're left with x equals minus 1. That's the axis of symmetry. Now to find the turning point, we substitute in x equals minus 1 into our original rule. So when x equals minus 1, y equals 2 times minus 1 squared plus 4 times minus 1 minus 3, which equals 2 minus 4 is minus 2, minus 3 will give us minus 5. So therefore, turning point is at minus 1, minus 5. So just to explain that again, what I've done here is I've just subbed in x equals minus 1 into our original rule to find the y-coordinate of the turning point. So now we've got all of the information we need to sketch. We've got the intercepts and we've got the turning points. So let's go ahead and do that. Alrighty, so here is a sketch of our parabola. We had the turning point at minus 1, minus 5. We had the x-intercepts at minus 2.58 and 0.58. And we had the y-intercept, which we found right at the start, at minus 3. And remember, it's really important that you label all of those points on your parabola.